happens that the lab 3 that we had really covers everything that we decided to cover. So there won't be any additional thing, but so maybe I can ask you all, have you done lab number 3 with all the different steps that Thien defined? Maybe each region can tell me, like the North, who can tell me if you finish all the lab number 3. Middle, Central, and South. Any of you? Dave, am I on? Can you guys hear me?
Yes, I can hear you. I'm not hearing any responses, and I'm not seeing any
Okay.
responses in the chat.
Okay. So
Students, can you let us know in the chat if you've finished these labs?
So I'm going to cover whatever I think is needed. My cloud is not responding.
Yeah, so the cloud seemed to be pretty slow today.
Yeah, I had problems earlier, and now right now it's just not doing anything. Yeah, and right before the class, I already asked Phương to reboot my machine, and he did, and now it's just if somebody have better luck, then can share the screen and I can walk through it, because right now I cannot do anything.
So the reporting in the chat is that everyone that's reporting so far says they finished the labs. Which you know all students have. A couple of students answered and said that they finished from yesterday or last week.
So I can my machine I can maybe I can pull up the labs, but give me some time though.
Okay.
Fook, thank you for that update. Fook is letting us know in the chat that they've been getting lots of delay since Wednesday.
Yeah, okay. So I am experiencing, it looks like the capacity has changed or something. Used to be okay, but nowadays it's very difficult to do anything. Let's see. Yeah, it's come to a halt.
So this is lap 3, EP1, right, Phil?
Lap 4. Yeah, lap 3.
Yeah, because 4 it's nothing there. Okay.
Yeah. Can you bring up?
Yeah, I'm about to bring it up.
Okay, so you have better luck. Let me stop sharing, and you can share, and then I'll ask you to do different things.
Yeah, I'm sharing. Okay, so I'm gonna take over the sharing, okay?
Yeah, go ahead. I already stopped sharing.
I think I'm in screen 1. Let me know if you see the right screen.
Yeah.
So okay, so I just import the design. So let me run a couple more steps.
Yeah, can you show me the script that in lab 3, right?
Yeah, let me rearrange the lab real quick. It's a little slow. Okay, so I'm gonna short the place instance.
Yeah. And run place adjustment.
Okay, so
How come you don't have the the trial? Can you look at the script? Look at the script directory. See if you can have.
yeah, PG string. Let me add all this.
Oh, okay. Yeah. Just run through. Just add PG strip. Yeah. Don't run the last one. Okay. So now look at the last one. I want to. Look at run place early route. Look at that file. Right.
Why can't it be there? Oh, I'm actually inside of the script. Run place earlier, right?
Yeah, yeah. I want to see what they are.
Let me open it a little bigger. Okay, so Thien has it's actually run the placement of the design.
No, we don't. You put
Yeah.
it into true and do a place design. I want to show them something. So set the do a true before it plays change false to true, right?
It'll be a lot
Yeah.
quicker. Yeah.
Yeah. So student, what we do is that we're going to run a quick place design in the floor plan mode, meaning that just go ahead and run it and zoom into the standard cell. I'll show
Yeah,
them.
well, let me show them that before we zoom in, because this is actually part of the placement I was going to do. So let
Yeah.
me turn in all the nets.
Right.
So you can see this is actually part of the placement I'm going to talk about. But you can see this is the core area for the placement, right? For the standard
Right.
cell. So
Zoom in and show them I don't know if Tien showed them the rows. Maybe he did.
yeah, I was gonna. This is part of the placement, but this is the row here. You can actually turn on the turn on and off the row right here. Let me expand. So
Yeah,
you can
because
turn on and off the standard row,
right.
right?
Yeah.
And then you can actually see the site, which is the standard cell site, right? That he'll talk about. You can see those two. Okay.
Yeah, show them the thing, right? So yeah, show them the side.
Yeah. So
And show them the wiring. Yeah, the wiring tracks. There you go.
Yeah. So this is the different layers running across each of the colors represent different track. So this is a 9 layers design. You can see 0 to 9, right? So, so in the track, there's a preferred track and non-preferred tracks. I think Tim will talk about it more because you know that you have horizontal and vertical tracks. So the horizontal usually is one is horizontal on the odd go across, and then the even go vertically. Okay.
So preferred tracks. Yeah. So if you look at the tracks, I mean the router will follow the tracks, meaning that over here, metal one is what, horizontal or vertical?
It should be horizontal, yeah.
So metal one is horizontal, metal two is vertical. Yeah. But there are some and prefer, right? Non-preferred track. Sometimes it will go non-preferred to solve problems. So people will understand, right?
Usually very short distance.
Yeah. Yeah. Okay.
All right, I'm going to turn up the tracks. So students, you can see this is the standard cell. This is the row where the standard cell is going to be placed. I actually going to talk about this in the next lesson, but we'll go talk about it here. All right, so we're going to run the placement, the quick placement. Actually, until you want to run I turned it to true, so it's going to take a little bit longer, but I think it'll be pretty quick. I'm going to run it.
Yeah, this is very quick, right? Yeah. And I want to load, or maybe we have, because place design will take a few minutes, so I don't know if we want to wait or we can load it. Right?
It's actually it won't do any. I mean, it's this one's pretty quick. We're not running optimization in post optimization placement, so
no, but I want to show them something. Right? Just
okay.
finish with this and zoom in and show them that the standard cells are not legally placed.
Actually, this place is actually going to legalize a place, so it does the detail placement part of it also. So you will not see that.
No, it won't. This is floor planning mode. It
will
do that.
Wait, did you actually we did the floor plan mode true or false? Oh, okay.
True.
Yeah, true.
We do,
yeah.
right.
Okay.
So it will be legalized. So that's what I want to show them. When you zoom in, you show the standard cell, right?
Sure.
You probably do full because this is very like 10% utilization to do full. All right.
So you can see the cells right there, right?
Yeah, right. So zoom in here and show them that they are turn off the
we turn off the
pins, right?
Pin.
You already did. All right. Okay, so student, you can see here. You see the rows and you see the standard cell are not legalized.
Right. It's not
this is a quick placement during floor planning to help you analyze the design. And then I want to show them the placement. It take maybe a couple of minutes. I don't know. Can you check if we can load it? Check the DB to see if it is already ran somewhere.
Check which one?
Go to the directories and check the DB directory to see if there's a database that already ran.
Oh, we haven't saved it yet, Neil. We got to save it, right?
No. If yeah, you don't need to save it. I just want to show, maybe you load the route ER, and I want to show when you actually do the place design, you will see.
You want to look at the DB directory?
Yeah, go ahead, DB directory.
Okay.
No, it doesn't have it.
What are you trying to do?
I want to look that when you and I wanted to understand the
This meeting is being recorded.
It's a place that sorry, place ECO. I keep messing up. Is it place? Or
you probably won't be able to do it because you don't have a full placement yet. Might as well just do set to force and do place design. It might be faster to then figure it out. Yeah. So do set DB to force and do place design. Yeah. So student, this is so two modes, right? One is early on during the floor planning. You want to do a quick one without really doing the placement optimization. So that means that all these cells are in the general areas, but they are not legalized. You see, they're not on top of the rows. And now you run the actual detailed placement, then these cells will be placed, onto the rows.
yeah, notice it does 2 iterations, right? It actually go through several iterations until it find a good solution, and then it will stop. It's iteration process. Actually, this design is all IP dominant. It's good for floor planning.
Yeah, because it serves a purpose, right?
Yeah,
Place
so
the macros and all these IOs.
so for the placement and the CTS, I'm actually using the different designs, so it's actually has a lot more standard cells, so it can demonstrate.
Yeah,
I need
right.
the CTS and so on. So
Right. So trong khi chờ đợi thì chắc tôi cũng muốn cái đây là cái kết luận của cái floor planning, thì hy vọng là đây là cái bước cũng là một trong những cái bước cụ thể nhất của vấn đề thiết kế vi mạch vật lý, thì mong mọi người hiểu. Và cái cách học đó là mình phải hiểu cho kỹ từng phần. Khi mình làm á, nếu mà mình làm floor planning mà làm không đúng á, thì những cái bước kế tiếp là mình sẽ không có làm được. Ví dụ floor planning làm mà nó không có bị airdrop, nó không có được tốt lắm á, thì khi mà mình làm để mà làm cho ship chạy nhanh chạy chậm thì nó không có đúng. Mình làm học xì dầu nhưng mà kết cuộc lại là nó sẽ không có đạt được yêu cầu. Thì mỗi bước đều rất là quan trọng. Thì cái chiến lược là làm mỗi bước mình phải, khi mà những cái bước đầu tiên, ví dụ ở đây mình về vấn đề mà tôi nói tiếng Việt để mà có thể là cho mọi người phải nắm vững cái hiểu rõ cái sâu của cái này. Ok, nó xong rồi. Can you show them the legalization?
Yep.
Yeah.
Yeah, so you can see
Yeah.
it's actually a line, right? So
Right, and show them the orientation if it's just to
yeah,
remind
so
them of, right.
let me turn on. You can see it's actually you can see it's on top of the roll, right? It's a line on the roll. So you can do a Q on this. You see orientation here. There's four legalized. There's four legal orientation, and you can see this is MX, right? So that's basically says it's mirror the x-axis.
M
Right.
is mirror and axis, yeah.
Right. Yeah, so this one should be M0 right here. So it's sharing VDD of VSS. So this is R0. You can see that that's the original. So if you flip the x-axis, it'll be on X. You flip it on the Y, it'll be a MY.
Yeah, you see the angle, and turn on the pin to show them these are abutment, meaning that the VDD and VSS are touching each other to double the width, right?
Let me turn on the net. Hold on.
Yeah, net name. So you see.
Oh, shoot.
Turn off signal, right? Yeah.
Yeah. Something else.
Yes.
Let me turn off the top layer. What happened? Sorry. I mean to turn it on only
Metal one, right?
metal
You just
one.
turn off everything, right?
Right.
It's slow, so that's why.
Yeah, so you can see
Yeah.
here the VD, these are internal pins, but this is a shared VD net, so there's half of on this pin and half on the other side. You can see.
Right.
And then on the
Right.
top, you'll share the VDD right here.
Yeah.
Yep.
And show them how VDD is going from the top layers to this metal
Okay.
one rail, right?
Okay, so let me turn off the sales pin. A little slow, but bear with me. Okay, so I'm going to turn on, it's called VO1.
And metal two.
Let me turn off the clock nets also.
Yeah. Just turn on power only, right? Special net, turn off everything.
Yes, so let me find a upper rail and then zoom in that area first, because it needs to have upper rails. Okay, so I'm gonna. What happened to all the vias here? Actually, it doesn't via up.
Might not be in that area.
Okay, I can see the via between these two layers, but I don't see from the lower layers. It should be coming up here along these guys. So maybe Ting had a bug in his script that actually didn't do it.
Okay, all right. So
Yeah, it looked like it should have come up along these lines right here, but I don't see it at all.
Okay.
Yeah, so basically, it's actually go up from this is a metal one. It's gonna via up according these guys here up all the way up to this layer, which is metal 7. Yeah, this is metal 8. So it should have all the vias stack coming up from 1 all the way up. But it looked like it has a bug in here that it actually didn't. We don't have it here.
Can you see if you can tell how it goes from the very top to whatever? Just show them how the power grid is built, regardless of the vias.
Yeah. So let me walk through the. So let me go metal 9, right? We have metal 9 going across, right? And then we have metal 8 going vertically. Actually, this is via 8. So to connect between metal 8 to metal 9, we need a set of via. So this is via number 8. You can see it come up, right? And let's see if we have anything else. It looks like we have 8 and 9 and then metal 1 only. So
Yeah, show them how the power grid is connected to the rings of the
yes.
Yeah.
So you can see so here's the ring, right? The ring is on metal 8. You can see 9 come across, right? So the power distribute internally to the core to all these connection, right? So so when it goes through here for the metal 1, there should be a set of via coming up whenever the metal 1 across each of these vertical stripes, right? So for IR drop analysis, depends on how far distance it will be, but it should come up on metal 1. We should have a set of vias coming up wherever the blue is crossing. So there should be a set of via from 2, 3, 4, 5, 6, 7 metal to connect these one all the way up. Each one of these metal 1. Okay, similarly what we have here on metal 8 and 9. Okay, so and then to the core, we should have a set of from the power pad. Let's see where the power pad are. Okay, here we go. So there should be a set of power pad, wherever the power pad, there should be a metal going across, either on, should be on 9 go across. 9 or 7, but should be on, I think on 9. So we didn't have anything on the left. So it looked like there's also a bug script that it should have connect the power pad coming in. So we don't have any. It should come from on both sides, all 4 sides. Yeah, it doesn't look like we have that connection made, Phil. But
Okay.
assuming this is a power pad, okay? Assuming this is a power pad, so it will connect. There's a power pin here. It'll come in and tap into this. Usually on metal 9, whatever layers. Usually on higher layers, metal 9 or 7, go across here. So if there's 8 on the side, there'll be a tap coming in just like this. Okay, it'll be like this. I can draw one. Create a special wire net VDD. Horizontal metal 9 with 2 micron maybe. So it'll be somewhere here like this. Oh, a little slow. Yeah, it'll be something like this, right? But if it was power pin and just tap to it, it should be wider than this. I have it 1, but it probably can be 2. So this is just a way of manually creating the power. So it'll tap in. So
Yeah.
it's something like this. Okay, I have a tab. So you can see this VDD. It only tap and create the via automatically based on this form that I created, right? So I tell it to go create a via crossover via. So it might tap in. So if there was a target VDD on this pin, it will actually make a connection right on it. around top of it. So that's what it should look like.
Okay. So there's a question. So let me try to address that. Anything else you want to show here? But
no, it's
there's a question about what are the issues we need to be concerned about for a good floor planning, a good floor plan.
So and Phil, that is part of the pre-check I do in placement. So we covered some of the placement already. I can share. I mean, you want to go ahead?
No. I can answer that question for now because it's because it's floor planning, but it's not a pre-placement, right? So but anything else we should be sharing with them for the floor planning part before we answer this question. Is that
no.
Yeah, maybe I can answer, and then if whatever else you can, let me try to share and I use some illustration to answer a very good question from Kan Yu. Let's see.
Okay, let me stop sharing. Okay, there.
Yeah. Am I sharing?
Yes, I can see.
Overview, right? You see the overview?
Yes.
Okay, so very good question. Xin lỗi, không biết Khanh hay là Khánh. The question is, what are the most important, what determines a good floor plan, right? What are the most important things? So we can review the floor planning, right? The step. The purpose is to create a design that is ready for the placement optimization, in which the location of all these cells and the sizing of the cells, everything is taken into consideration for a good time enclosure and minimum die size and minimum power, etc. But the placement is determined by the floor plan, and the floor plan is determined by different things, right? So the process of floor planning is you define the chip size, you place the IO cells, you place the macros, you define the standard cell areas, you create a power grid, and you route any special nets. So that is a review of a floor planning, and the output will be something similar to that, right? So what determines a good floor plan? First of all, what determines the cost of the chip is the die size. So the floor plan, the most important thing would be determining the locations of all these macros, the standard cells, the IOs, and the size of it. So let me go to that picture. Maybe this picture. So the most important will be related to cost, right? Cost meaning that you're given a function, you're given some constraints, how fast, right? Where are the IOs should be, how fast, how low power. If you have a chip that is put on an iPhone, what is the current drawn for the function that it needs to perform? So the competitiveness, the die size determine the cost, how much it costs Apple for the chip components, right? That determines the final cost, the competitiveness of it. So now the die size really determine on how well you do all these optimizations, because at the end of the day, you put all these macros in the locations that will help you achieve time enclosure with the minimum die size. Help you achieve the functionality with the minimum power consumption. So if you don't do it right, you will cost more, you need more gate to implement a function to achieve the speed. You need more power to achieve the functionality, the processing. So if you don't have the knowledge, then you won't be able to perform. So it's not as simple as something that you pay attention to, but it's a lot of knowledge going to that we already went through. One example for that is could be like this one in terms of a DSP. You have a program that's really you fetch instruction and you have series of signals that's sampling from the RF or the microphone and going in as a series of signal. You need to do filtering by having the samples, loaded into two RAMs, and then you operate an FFT. That means multiply, accumulate using a coefficient RAM, etc., and then store the result back and do all sort of operations. And that is the number crunching operations. And if you don't know that, and you put XRAM, 2 XRAM over here, and you have coefficient RAM over here, then the buses that are between them are farther apart. So it will be harder to meet timing, and it will consume more power because you keep on switching all those buses. So that's one example of the importance of floor planning. So it's in terms of die size. And two will be timing closure, right? If your Apple chip needs 2 gigahertz and you don't do floor planning right, you will have hard time just going on and on and on, and you don't meet timing with the target frequency, with the target process. And then even if you do that and if you don't do it right, you will consume more power, right? Than your competitor, and you don't understand the static time, the static power component of it, the leakage, how leakage relate to the cell area, etc. You don't know that, you don't do the right optimization. So performance PPA is all about PPA, right? Performance is a speed, P is another power, and A is the area. So is everything that we do, including the floor planning, relate to that. So I will share with you another list that I thought I brought it up, but let's see. Okay, this is what I found on the internet, and I share with you. I think I shared in the reading, but that's a list of things that you want to qualify the floor plan with. But none of the things that I just spoke about are in this list. So these are the things like no IO port shorts, macros have to be in placement grid. I didn't even pay attention to it. No macro overlapping. Check the PG connections, make sure all the macros and cells have the powers. Make sure all the macros should be placed at the boundary. All the guidelines that we went over, like it's a lot of things that we went over the last 4 lectures, right? They are, whatever we cover, they are part of the checklist. So it's like the guidelines mean that, hey, here are the things that are good for it. But if you look at the whole thing, and the end of the day, what impact does the floor plan, a good floor plan does, is that good floor plan will be doing what I just said. With the same functionality, you have the smallest die area, smallest will be lowest power consumption. That's a differentiation, right? If you do it right, you'll beat competition because the speed probably going to be similar for certain applications, but the faster the speed it is, the more competitive your chip is. So I hope that answer is a long answer, but that was it. You have anyone have any additional comments?
So and Phil, yeah, let me add a couple more things. So these are the things, but also the tool, usually the tool has some of the built-in command that will help you checks, for example, the things that are not placed on the grid, macros and things like that. So it does have some built-in functionalities that a command actually you can run and it'll spit out a report for you.
Right. And then also if you do a floor plan and you pass it to another person who does a placement, if you don't give enough area or the wrong placement areas for the macros, the design is not routable. So that's another thing. So you do during placement, which Bud will cover, right? Congestion, right? Congestion includes placement congestion, routing congestion. If it's not, you don't do it right, you have congestion that you will not have routable design, meaning that you can route all the signals, but you won't be DRC clean, right? That's another thing that will have an impact if you don't do it right. And also, if you don't do it right, you won't be able to meet timing like I mentioned. Ok, chỉ còn 3 phút nữa thì đến đây là chấm dứt những gì tôi giảng dạy trong này. Tôi sẽ tiếp tục phụ, nhưng mà tuần sau là Bạch sẽ bắt đầu giảng dạy, thì giống như tôi đã nói rồi, sau đó cuối cùng là Thiện. Thì hy vọng là cái cách dạy bằng tiếng Anh sẽ giúp cho mọi người làm quen với lại những cái đối thoại và những cái chi tiết kỹ thuật về tiếng Anh, tại vì cuối cùng mình làm cũng môi trường bằng Anh ngữ. Thì nhưng mà nếu mà có những cái câu hỏi gì mà chuyên sâu quá mà cần giải thích bằng tiếng Việt thì mình cũng có thể là trang vào đó nếu cần thiết. Mình không có muốn, nếu mà không cần thiết, mình muốn cố gắng mình học tiếng Anh và mình đàm thoại bằng tiếng Anh. Lần đầu mình nghe tiếng được tiếng mất, nhưng mà hồi là mình sẽ nghe được giỏi. Nhưng mà nói chung là những cái người đã tuyển chọn ra trong này là đều là có trình độ tiếng Anh rất là cao rồi. Thì hy vọng là những cái cách giảng dạy bằng tiếng Anh thì mọi người có thể hiểu được. Và cái flip classroom là cái mục đích chính là để những người nào mà chưa quen được tiếng Anh thì mình có thể là nghe lui nghe tới, hoặc là đọc lui đọc tới được. Thì hy vọng cái mô hình làm flip classroom này là rất là hữu dụng cho mọi người. Thì sự cảm ơn là sự chuyên cần học hỏi của các em sinh viên và các giảng viên, và cũng cảm ơn những cái sự hỗ trợ của mọi người. Thì hy vọng là những cái gì đã được dạy thì nó hữu ích. Và đừng quên là cho chúng tôi biết những cái phản hồi, những cái gì có thể làm được để mà có thể dạy được tốt hơn. Thì xin vui lòng có thể là chia sẻ ở ngoài, hoặc là nếu mà muốn thì chia sẻ riêng tư cũng được. Một lần nữa cảm ơn mọi người nhiều.
Thanks, Phil. I will, starting next week, I'll send out assignments and pre-assessments for placement and slides. Probably I'll send out by Monday.
Thank you, Bạch. Alrighty. Cảm ơn mọi người. Chúc mọi người một ngày vui.
The recording has stopped.